Auzubillahiminash-shaytanir-rajim. Bismillahir-rahmanir-rahim. I am Dr. Mushtaq Ahmad. I am here to teach you on line lecture today due to the lockdown. Due to the lockdown in the Punjab. So today class will be online, and in this lecture, uh, we have to discuss what is the equivalence relation. The equivalence relation is a sort of the binary relation that should be reflexive, symmetric, plus transitive in the nature. The well-known instance of the equivalence relation is the equal relation. In the other world, we can consider when two elements of the provided set are equivalent to each other if they relate to the same equivalence class. Condition for the equivalence relation, there are three conditions. One is the reflexive, other is the symmetric, and the third one is the transitive. A relation R is a reflexive, then all the elements of the given set are mapped with itself such that for all A belong to a set Q, then A, comma A must be belong to R. In this way, we can say that R is a relation on the set Q. The relation R is said to be symmetric on a set Q if A, comma B belong to R, then B, comma A also belong to R such that A, B belong to Q. Consider here an example. Let if A is a set containing the three elements 3, 4, and a 5, then the R is one of the relation on the set R. You know that as A3 contain the three element and A cross A contain 9 element. So A cross A, yani Cartesian product of A with A contain 9 element. In this way, we can define at least 512 binary relation on a set A, and R is one of the 512 relation. And now we have to check is an equivalence relation. If it satisfy all these three conditions, reflexive, symmetric, or a transitive, then we can say that R is a equivalence relation. Let's check in term of the relation R is a reflexive, symmetric, and transitive as shown above previously. In terms of the mathematical concept, the binary relation over the set AB denoted by a set Cartesian product A cross B consisting of the component of the form AB such that A belong to B and B belong to if and only if the three conditions that are reflexive, symmetric, and transitive is not supported. Uh, the relation cannot be an equivalence of one. The equivalence type of the relation is commonly expressed by the symbol. This symbol, the proof of the equivalence relation, a binary relation on a set, on a given set, is supposed to be an equivalence relation if and only if it is a reflexive, symmetric, and transitive. For all P, Q, R in a set X, P also reflexives to P, yeah, P also related to itself. So this property of a set is called the reflexivity. If P relate to Q, if and only if Q also relate to P, so this property is called symmetry. If P relate to Q and Q relate to R, then P relate to R. It is called transitivity. To learn how to prove if the relation is an equivalence, one and determine how many equivalence relations are on a set. Let us consider some example. Number one, specify a relation P on a set of the natural number xy belong to P. Here P is a set of a natural number if and only if x is equal to y. Now we confirm that the relation P is a reflexive, symmetric, and transitive because we have already discussed the well-known equivalence relation is an equality. Now we will confirm that the P is a reflexive, symmetric, and transitive. Reflexive property, since each natural number is equivalent to itself, that x is equal to x for all of x belong to n. So in this way, the pair of x with itself also belong to the P. For all x belong to natural number. So therefore P is a reflexive. So P here is a relation on the set of natural number n. Symmetric property, if x, y belong to natural number, then x belong to P and x is equal to y. This implies that y also belong is equal to x. This implies that y comma x also belong to P. Since x, y are the arbitrary P are symmetric in nature. Transitive property, if there are a three natural number and we pairing these three number in such a way, x with y also belong to P and y belong to z also belong to P. This implies x is equal to y and y is equal to z, and by the property if x is equal to y, y is equal to x, then x must be equal to z. If x is equal to z, this number similar to same number of the equivalence to another. So in this way, the order pair of x and z also belong to the relation P. So this relation P fulfill all three axioms of the equivalence relation. P is a reflexive, P is a symmetric, and P is a transitive. We can say that P is an equivalence relation. So P is an equivalence relation. Sorry. Here are some short example of the equivalent relation. The equivalence relation can be explained in terms of the following example. The symbol is equal, which is denoted by symbolically in this way on the set of the number character or a symbol. For example, 1 over 4 is equal to 2 over 4 for a set A for all element P, Q, R belong to A, where P is equal to Q, P is equal to Q and Q is equal to P is equal to Q is equal to and R is equal to. So in this way, we can say that already we have discussed the equality is a equivalence relation because equality fulfill all three axioms of the equivalence relations: reflexive, symmetric, and transitive. For an assigned set of the triangle, the relation of the similarity to denoted by this is a congruent to confirm the equivalence that is they are reflexive, symmetric, and transitive. Yeah, and it's mean there is an equivalence relation between a set of the triangle of the equilateral triangle. Here is an example. Another example prove that R is an equivalence relation equivalence type in a set P, where here P is a set three containing the four element 3, 4, 5, and 6 given by the relation R. The relation R is defined such as containing the order pair by which the difference of these element, the element which making this order pair, the difference, absolute difference is an even number. Let R is PQ and P minus Q is an even where PQ belong to P. In this way, if P minus Q belong to is even, then we can say that P related to Q. Now we check the reflexivity from the provided relation P minus P. So, according to the definition of the relation, P minus P, if P minus P is an even number, we can say that P related to P. And as you know that P minus P is equal to 0, 0, absolute value is equal to 0. 0 is an even number. So we can say that every number of this set is related to itself. This thing justify the reflexivity of the relation. And 0 is always even, therefore P minus is even. Hence, we can say that P comma P related to R. So R is reflexive. Now we check the symmetric property. From the given relation P minus Q, we can write is Q minus P, because if you take the minus common, we can write it as Q minus P by the absolute value. Both have the same value because minus will be omitted according to the definition of the absolute function. We know that P minus Q is equal to minus Q minus P, and this minus will omit Q minus P. Hence, P minus Q is an even. Next, Q minus P is also even. According to if P comma Q belong to R, then Q P also belong to R. So we can say that R is a symmetric. Now we check, is it transitive? If P minus Q is even, then P minus Q is even. Similarly, if Q minus R is even, then Q minus is R. So even. The summation of the even number is 2 even. So we can address it is P minus Q plus Q minus R is even. Then Q say Q cancelled out, plus minus Q cancelled out, plus Q. So next P minus Q is further even. According P minus Q and Q minus R is an even, then P minus R is also even. Consequently, the order pair PQ belong to R and QR belong to R. Then we have proved that PR also belong to R. Therefore, R is a transitive. So this relation fulfill all the three property, all the three exams: reflexive, transitive, and symmetric. So this is a equivalence relation. Here is another example: A, 2, 3, 4, 5, and R is equal. Confirm that R is an equivalence relation. We can justify R is a reflexive, R is a symmetric, and R is a transitive. Easily, set A containing the 4 element, its Cartesian product contain the 16 element. So there is more than more than 1024 relation. So R is one of them relation containing 1, 2, 3, 4, 5, 6, 7, 8 order pair. We are going to prove that R is an equivalence relation. Reflexive, R is a reflexive because every order pair which relate to itself also in this relation, because 2 2 is also in this relation, 3 3 also in this relation, 4 4 also in 5 5 also. So every element related to itself in this relation, under this relation, so this relation is a reflexive. It is also symmetric, as AB belong to R, B also belong to R, as you know that 5 3 belong to R, and 5 3 also belong to R. This relation is a transitive. Whenever A belong to B and B belong to C related to R, A belong to C also related to R. You can check by this 3 5 belong to R, 5 3 belong to R. So in this way 3 3 belong to R. In this way you can check an other pair of the three element and other three order pair. You will find R is an equivalence relation, R is a transitive. R is reflexive, R is symmetric, and R is transitive. So R is a equivalence relation. Now we define the equivalence class. An equivalence class is a subset of B such that a way A comma B belong to R for all A, B belong to B, then A, B cannot exist outside of a B. Mathematically, an equivalence class of an element A of a set is expressed A square brackets is equal to X belong to A. So in this set contain the such element which make which make the pair which contain the element come from A, that element which make the pair with A under the relation R. So A comma X belong to R, which include the all element of A which are linked to A. Yani in other words, all the relative of A come from the set A under the relation R, form an equivalence relation of a set of an element A. All the element of A equivalent to each other refer to the same equivalence class. Here we discuss the another definition, partition. A partition of a set A implies a non-empty set of a adjoining subset of A such that none of the element of A is in the two subset of A, and element relating to the identified subset are related to each other. The union of these subsets in the partition is equivalent to set of A. Okay, thank you. And other example, quotient set definition. A quotient set quotient set denoted a set of A of all equivalence classes of an equivalence type related to expressed by this A over R is equal to A and A belong to A. In other words, the quotient set contain the all equivalence classes of a set A. थैंक यू, आज के लिए इतना काफ़ी है। तो बाकी इंशाल्लाह नेक्स्ट वीक मिलेंगे। अल्लाह हाफिज।